All right, here we go. 5-6 video, parallel and perpendicular lines. After this lesson, I will be able to determine whether lines are parallel, perpendicular, or neither, and write equations of parallel lines and perpendicular lines. Stop. Make sure your volume is on. You got to listen because there's all kinds of stuff that is not written on the slides. Here we go. Two distinct. Distinct just means different lines in a coordinate plane either intersect, cross, or are parallel. All right, parallel lines in the same plane are lines that are in the same plane and they never intersect. Okay, so our big understanding for the section is we can determine the relationship between two lines by comparing their slopes and their y-intercepts. All right, so when I talk about slopes of parallel lines, in words, non-vertical lines are parallel if they have the same slope and different y-intercepts. Vertical lines are parallel if they have different x-intercepts. All right, since we know that vertical lines all have the same slope, namely undefined, as long as they're in a different spot on the graph, they're going to be parallel. All right, for example, the graphs of y equals 2/3 x plus 6 and y equals 2/3 x minus 2 are lines that have the same slope, which is 2/3 in this case, and they have different y-intercepts, 6 and -2. So the lines are parallel. Same slopes, different y-intercepts. All right. Non-vertical lines are parallel. If they have the same slope, different y-intercept. Okay, so if I look at this picture on the graph, the red line has a slope of 1/2, up 1/2, and the y-intercept is at 1. The blue line has a slope of 1/2, and the y-intercept is -2. So those lines are parallel because they have the same slope, different y-intercept. Okay? Cool. We can use the fact that the slopes of parallel lines are the same to write the equation of a parallel line to a given line. So here's problem 1. A line passes through 12,5 and is parallel to the graph of y equals 2/3 x minus 1. What equation represents the line in slope-intercept form? Okay. So, first thing we better figure out is parallel lines have the same slope. So we know already that the equation that is going to be parallel to is in slope-intercept form. So I know I can identify the slope is 2/3. Okay? So I know my new line will have that same slope. Okay? And we have a point that it's going to go through. So we can use point-slope form because we have a point and a slope. So the point would be 12,5, and the slope would be 2/3. So if we just put it into point-slope form, there's point-slope form again for you, and we just put it in, it'd be y minus 5 equals 2/3 times x minus 12. Okay? So if I wanted to put it into slope-intercept form, well, all that means is I have to get rid of the 2/3. I'm going to distribute the 2/3, which would become 2/3 x minus 8, because I have to go 2/3 times x and 2/3 times -12, which is -8. Now I got to get rid of this minus 5, so I'm going to add 5 to both sides, and I'm going to have y equals 2/3 x minus 3. Okay, so that's in slope-intercept form. Great. Let's take a look at another example. I'm going to go through -3, -1. I'm going to be parallel to the graph y equals 2x plus 3. Again, parallel lines have the same slope. That line that they gave me is in slope-intercept form. So I know I can identify the slope pretty quickly. The slope is 2. Now I have a slope and a point, -3, -1 as my point, and the slope of 2. I'm just going to plug it into point-slope form since I have a point and a slope. Plug it in. Remember, don't forget your minus negatives come up a lot when you have point-slope form. So if I want to turn that into slope-intercept form, I have to distribute the 2, subtract the 1, and I'm at y equals 2x plus 5. Okay, so same slope, parallel, and then use your point, use point-slope form, and then convert it to slope-intercept form if that's what they want you to do. Great. We can also use slope to determine whether two lines are perpendicular. Perpendicular lines are lines that form right angles. Okay, so slopes of perpendicular lines. Two non-vertical lines are perpendicular if their slopes are opposite reciprocals. A vertical line and a horizontal line are also perpendicular. Okay, so for example, the graph of 2/3 x plus 6 is a slope of 2/3. The graph of negative 3 halves x plus 6 has a slope of negative 3 over 2. Those numbers are opposites and reciprocals. Opposites, one's positive, one's negative. Reciprocal just means you're taking your fraction and you're flipping it over. Since the slopes are opposite reciprocals, these lines are perpendicular. All right? So slopes of perpendicular lines are opposite reciprocals. If you notice the picture on the graph, red line has a slope of 1 over 2, up 1 over 2, from any point to any other point, up 1 over 2, up 1 over 2. The blue line from an easy point to another easy point is down 2 over 1. So the slope of the blue line would be negative 2. Those numbers, 1 over 2 and negative 2 over 1, basically, are opposite reciprocals, so the lines are perpendicular. Okay, so let's take a little closer look at that opposite reciprocal idea. Opposites means one's positive and one's negative. Reciprocals means you exchange the numerator and the denominator of the fraction. In other words, you just flip the fraction over. Okay, so a couple examples. 2/3, if I flip that, it would be 3 over 2, but one's positive, one's got to be negative. So those are opposites, one positive, one negative, and I flip the fraction. So 5 over 2 is going to become negative 2 over 5. Negative 1 over 3, well, this one's got to be, his partner's got to be positive, and positive 3 over 1, which is just 3. 7 over 3, well, he's got to become negative 3 over 7. 5, well, 5 is really 5 over 1. So my new number's got to become negative 1 over 5. Negative 4, well, the new number's going to be positive, and 4 is really 4 over 1. So it's going to be positive 1 over 4. 1, well, 1 is just 1 over 1. So negative 1 over 1 flipped over will be negative 1 over 1. And then negative 3, well, negative 3 is really negative 3 over 1. So positive, and flip it, be 1/3. Okay, so that's what negative reciprocals, some examples of those are. Are the graphs of the following lines parallel, perpendicular, or neither? Well, if I can get it in the slope-intercept form, it's very easy to find their slopes, and then I can judge from there. So the first one, in order to get in the slope-intercept form, we'd have to get rid of that 4 in front of the y, because slope-intercept form, y equals mx plus b. So I'm going to divide by 4. When I do that, I have to do is all of the pieces, because I'm dividing, so all of those pieces. So when I do that, I would wind up with y equals negative 5 over 4, x plus 3. So since I can't really divide 5 over 4, just leave it as a fraction. So negative 5 over 4. I could divide 12 over 4, so I just made that 3. All right. Now, if you look at your two slopes, negative 5 over 4, and the good thing about this second problem is it's already in slope-intercept form. So I can find his slope, very simple, 4 over 5. So those numbers are opposite reciprocals. So the lines are perpendicular. One's positive, one's negative. The fractions flipped over. Those are opposite reciprocals. Lines are perpendicular. All right, here's another example. So the first one is already in slope-intercept form. That's good. I know that the slope is 3 over 4. All right, the second one I got to put into slope-intercept form. So I got to get the y all by itself. Remember, when I subtract 4x from both sides, I can't subtract it from the 9 because they're not like terms. So I have negative 3y equals 9 minus 4x. Divide the whole problem by negative 3 to get rid of that negative 3 in front of the y. And I would wind up with y equals negative 3 plus 4/3 x. Remember, negative 4 divided by negative 3 is positive 4 over 3. Now this isn't quite in y equals mx plus b form. It's just flipped around these two parts. But important to note that this number right here is the slope. Okay? So if you compare your two slopes, 3 over 4 and 4 over 3, well, those numbers are not opposite reciprocals. They are reciprocals, but not opposite reciprocals. So both lines would be going up. So there's no way for them to be perpendicular and make a right angle. The slopes are not the same, right? So they're not parallel. Therefore, this one would be a neither problem. I mean, it's parallel, perpendicular, neither. Okay? So that's it, my friends. I'll see you next time. Peace.